Chapter 1, Exercise 15. Utilize the proof of the Schwarz inequality, Theorem 135, and the notation therein. Consider the cases b equals 0 and b doesn't equal 0 separately. Use the identity here. First, recall the Theorem 135, the Schwarz inequality here. Now set the following: A, B, and C. If b equals 0, then each bj equals 0. See Theorem 133a. So both sides in the Schwarz inequality are 0, which means that inequality is actually an equality. Now assume that b greater than 0. By the proof of the Schwarz inequality, Theorem 135, we have this. Hence, the equality holds if and only if ab minus absolute value c squared equals 0. That is, if and only if each term in the sum is 0. Baj minus cbj absolute valued squared equals 0. By Theorem 133a, this is further equivalent with the fact that baj minus cbj equals 0 for each j equals 1 to n. Thus, the equality holds in the Schwarz inequality if and only if bj over aj equals c over b equals a constant for each j from 1 to n. In both cases, an equivalent formulation is that vectors a1 to an and b1 to bn are linearly dependent in Cn. According to exercise 11, if z equals this and v equals this are the polar forms of complex numbers z and v, then zv ultimately equals absolute value z, absolute value v, cosine theta plus phi, plus I sine theta plus phi. Here is a picture. Thus, the geometry of multiplying complex numbers is based on the following. Add the angles and multiply the magnitudes. In other words, a rotation and scaling. Hence, equality holds in the Schwarz inequality if and only if the ratio of the lengths and the differences of the angles between the vectors aj and bj are constant for all j from 1 to n. Note that the angle between the blue vectors or red vectors is equal to the black angle. That means arg of ai equals theta plus theta I. Here is a picture. The equality holds in the Schwarz inequality in case n equals 2, and ai is parallel to bi, that is, m is an element of real numbers. As noted earlier, the angle between blue vectors or red vectors is equal to the black angle, that is, arg ai equals theta plus theta I. In the particular case when theta equals 0, the blue vectors and red vectors are parallel, that is, they lie on the same line. This fact also occurs when theta equals pi, but in an opposite direction. Thanks for watching.